All right, class, this is example 1, page 449, 8.4. This section is 2 prop z-test. Hopefully you've read through all of the material up to page 449 in this section. Okay, and again, just a reminder, hopefully you're doing all the book problems also, as well as the online, because the book problems, if you do those, you're going to learn a little bit more than just doing the online problems. But okay, so anyways, here's the question. I'll let you read it. I'm not going to reread it. I'll just read the bottom part. Can you reject the claim that the proportion of occupants who wear seatbelts is the same for both vehicles? Okay, so is 86% of 150 and 74% of 200, is that the same relative proportions? Okay, we're going to test this at the 0.1 alpha level, or the 10% level. So we'll have to find the critical values for that. I'll show you how to do that. Again, you don't really need it to solve the problem. You just need to do it to do some of the online problems. Okay, so first thing we need to do is set up our HO and our HA. All right, so HO, it's going to be, it's pretty simple. 2 prop z-test, so HO is P1 equal to P2. HA is P1 not equal to P2. And according to this little passage, here's our claim. Okay, so this is our claim. Can we claim that this is true? Or do we have enough evidence to not support, but fail to reject? Okay. So the next thing we're going to do is find our critical values. Again, you don't need critical values for most of the actual problem. We can just use our p-value, but there are some online questions that require it. So the p-value, or the critical values, we're going to use, this is a z-test, so we'll use our inverse norm. Okay, and we want center. But remember, when you use inverse norm to find with the area, 0.1, you got to do 1 minus your alpha value. Okay. So our critical values will be negative 1.64 and positive 1.645. So we're here. Our rejection region will be here. And here, since it's two-tailed, these are our critical values, 1.645, negative 1.645. So again, just a reminder, if we end up with a z-score, or a standardized test statistic in this area, okay, we're going to fail to reject. If we're over here, we're going to reject. If we reject, that means we don't think that these are equal. Okay? If we fail to reject, well, then it's looking like they might not be equal. Okay? So how do you do this problem? Well, you actually just put these values right in to 2 prop z-test. Okay? So our x1 is going to be 0.86, and hopefully this doesn't turn out to be a decimal. If it's a decimal, then I'm going to have to round it, right? Or do it by hand. Good, it's not. It's 129. If that was a decimal, you'd have to round it and then know that your answer might be a little bit off. Hopefully, I don't think it's off far enough to get it wrong on the online. Whoops. Okay, 0.74 times 200. So what am I doing here? I'm taking the probability that a car user wears a seatbelt out of 150, and that was 0.86. And then the probability that a truck owner uses a seatbelt, that was 0.74 out of 200. Okay, and I want to choose not equal to, because that's our HA. Hit calculate. All right, so we get a z-score of 2.7, 2.73. Where does that put us? 2.73, it's way over here. So we're in the rejection region, and also with our p-value of 0.006, that is our alpha value, that is way less than our alpha value of 0.1. So if this is the case, we're going to reject HO, and so there is enough evidence to reject the claim that a proportion who wear seatbelts is the same for passenger cars and pickup trucks. Basically, we don't think these are equal. 0.74 and 0.86, there's a significant difference between those that wear seatbelts in cars and those that wear seatbelts in pickups. All right? Hopefully this helps.